Myself Archana Sharma from Noida Institute of Engineering and Technology, Pharmacy Institute, and I am here to deliver my lecture on the topic emulsifying agent. In the last lecture we have already discussed about the emulsion. Okay. So, what is an emulsion? It is a biphasic dispersion system which includes two immiscible liquids, okay, and the two immiscible liquids are stabilized with the help of emulsifying agent. So, in this lecture we study about the nature of the emulsifying agent and how they are going to stabilize the emulsion. Okay. So, first of all, emulsifying agent stabilize emulsion by reducing the collagen of the dispersed globules. These possess certain degree of affinity to polar and non-polar liquids. Okay. They act as a bridge between the polar and non-polar phase and reduces the interfacial tension such as, for example, of emulsifying agent span, acacia, twins, gelatin, etc. What happen when we prepare the emulsion, okay, whether we are going to prepare water in oil or oil in water type of emulsion, what we do? We disperse the one phase, that is called the disperse phase, into the other phase. Okay. This is a oil globule and this is your water phase. So, what happen when this oil globules, they have tendency to get collide, okay, and fuse to form a bigger globules, and afterwards they completely form a phase separation, that is oil phase and water phase. What this emulsifying agent do? They protect or they form a protective layering around each globules of the dispersed phase, thereby preventing the two oil globules from getting collide with each other. Okay. So, they prevent the collision of the two dispersed phase globules. How they prevent? They form a bridge between the polar and the non-polar globules. How they form? See, they are having a head and tail portion. Okay. So, one part is attached with the oil globule and the other is with the water phase, or the one part is attached with the globule of the dispersed phase and the other part is attached with the globule of the continuous phase. Okay. Thereby just like this, suppose if this is a oil globules, so they form a bridge, sorry, this is a oil, they form a bridge with the water molecule, then again this is a oil globule, then again, okay, with the water molecule and again like this. Okay. So, in this way they form a networking or a bridging between the polar and the non-polar phases, thereby preventing the collisions of the two phases. Okay. Next, another agent is your auxiliary emulsifying agent. These agents themselves cannot form stable emulsions, but act as a thickening agent and helps to stabilize the emulsion. Okay. So, auxiliary emulsifying agents are those agents which make the stable emulsions, but they do not act by reducing the interfacial tension, but they act as a thickening agent. They are going to increase the viscosity of overall viscosity of the system, thereby they reduce the mobilization or the mobilization power of the oil of the globules of the dispersed phase, thereby they prevent the collision between the two globules of the phases. Okay. For example, glyceryl monostearate, stearic acid, sodium CMC. Then another is your Bancroft rule, a very important rule which describe what type of emulsion will form, and it gives the relationship between the nature of the emulsion and the emulsifying agent. Okay, so Bancroft rule describe the relationship between the nature of emulsifying agent and type of emulsion formed. According to Bancroft rule, if the surfactant is more soluble in water, then the aqueous phase become continuous phase, that is oil in water type of emulsion will be formed. For example, of water soluble emulsifying agents are tweens, acacia, bentonites, etc. Similarly, if the emulsifier is more soluble in oil phase, then the water in oil type of emulsion will be formed. So, as per the Bancroft rule, the nature of the solubility of the emulsifying agent will decide what type of emulsion is going to be formed. If the emulsifying agent is more soluble in water phase, then the continuous phase will be more as compared to the oil phase. So, in this case oil in water type of emulsion will be formed, and same is the case is the if the emulsifying agent is more hydrophobic, that is oil soluble in nature, then water in oil type of emulsion will be formed. Next is your hydrophilic lipophilic balance. To determine that how much your emulsifying agent is polar or non-polar in nature, we determine with the help of its hydrophilicity by measuring its hydrophilicity and lipophilicity, that is called the HLB system. The HLB is an arbitrary scale, it is proposed by Griffin, that indicates the extent of hydrophilic lipophilic balance. So, as I said ki in your emulsion in the previous definition of emulsifying agent, that they contain affinity for the for both polar and non-polar groups. So, to determine how much it is polar and how much it is not non-polar, for this we design or we take a help of the HLB system. HLB value of 1 indicates that the surfactant is soluble in oil. HLB value of 20 implies that it is soluble in water. So, in the HLB scale here, this is the HLB scale. So, if we look in this HLB scale, if we move downward, the surfactant or the emulsifying agent is more lipophilic in nature, but if we go above, the surfactant or a emulsifying agent is more hydrophilic in nature. Clear? So, the HLB scale is used to identify the optimum efficiency of a variety of surfactant. So, method 1, how we are going to determine that HLB of value of any particular emulsifying agent or an surfactant. We for this there are 3 methods. First method is HLB is equal to summation of hydrophilic group number minus summation of lipophilic group number plus 7. Okay. Another method is HLB is equal to E plus P by 5, where E is the percent by weight of ethylene oxide chain and P is the percent by weight of polyhydric alcohol groups. Next, last method is method 3rd, HLB is equal to 20 into 1 minus S by A, where S is the saponification number of the ester and A is the acid number of the fatty acid. So, by using any of the 3 method, we can determine the HLB value of the emulsifying agent. Another important term that is called the required HLB. Okay. So, what is required HLB? and HLB number 1 to 20 represents the relative portion of the lipophilic and hydrophilic parts of the molecule. So, if we look into this figure, we determine that what we are observing, that from HLB value of 1 till 20, then the HLB scale is categorized into the certain values. For example, for 0 to 1 to 3, the emulsifying agent is more antifoaming in nature, then 3 to 6 water in oil type of emulsifying agent, etc., like this way. Then HLB number 8 to 18 indicates a hydrophilic molecules and produces an oil in water type of emulsion. So, from the HLB scale, the numbers from 8 to 18, that is the value of the HLB lies, if it is lies in between 8 to 18, that indicates that that your emulsifier is more hydrophilic in nature. So, what type of emulsion will be formed? Oil in water type of emulsion. Low numbers or a low HLB value such as 3 to 6 indicates a lipophilic molecules and produces a water in oil type of emulsion. So, if we go downward, such as the HLB value of 3 to 6 indicates that the emulsifying agent is more oil soluble. So, what type of emulsion will be formed? Water in oil type of emulsions will be formed. Oil and waxes material have a required HLB number, which help in the selection of appropriate emulsifying agent when formulating emulsions. For example, liquid paraffin has a required HLB value of 4 to obtain a water in oil emulsion and 10.5 for an oil in water emulsion. A blend of surface active agent are used in the preparation of emulsion. Required HLB is the hydrophilic lipophilic value that is desired in order to prepare a stable emulsion of oil in water or water in oil. So, what is a required HLB? It is a appropriate HLB value, that is only that value indicates that if you are going to choose the emulsifying agent of particular range of the required HLB value range, you will form a stable emulsion, whether it is a oil in water type of emulsion or water in type of emulsion. That HLB value is also known as critical HLB. It is also known as critical HLB. It is assumed that HLB of a mixture of two surfactant containing fraction F of A and 1 minus F fraction of B is an algebraic mean of two HLB value. So, how we are going to calculate the required HLB value? That is what we do, we take a HLB value of the mixture, that is if we are going to take the two surfactant, then what will we do? We will take the fraction F of A and 1 minus F fraction of B. Okay. Then the summation of the two will give you the required HLB value for the mixture. Then another technique is here, the HLB phase inversion temperature. Okay. This method extends the HLB method to include a characteristics property of the emulsion, the phase inversion temperature of the system. If an oil in water emulsion is stabilized by a mixture of non-ionic polyether surfactant is heated, phase inversion from oil in water to water in oil emulsion will occur at a specific temperature unique to the particular emulsion. Phase inversion can be easily seen visually. So, what they do in this technique, what happen, that at a particular temperature there is a transition in the phase occur. So, at a particular temperature what will happen, phase inversion, that is if we have prepared oil in water type of emulsion, what will happen, it will converted into the water in oil type of emulsion at that particular temperature. That particular temperature is called HLB phase inversion temperature, and it can be easily seen visually. The phase inversion is based on the act that the stabilities of the oil in water emulsions containing non-ionic surfactant are closely related to the degree of hydration to the interfacial films. Oil in water emulsion will form if the surfactant is predominating hydrophilic, whereas water in oil emulsions are produced when the lipophilic part of the molecules dominates. So, as temperature increases, the HLB value of a non-ionic surfactant will decreases as it becomes more hydrophobic. So, this type of inversion is more seen with the non-ionic type of surfactant, as we all know that if oil in water type of emulsion will form, that means that water is in continuous phase. So, that your emulsifying agent or surfactant is predominantly hydrophilic in nature, that is why oil in water type of emulsion is formed. So, so what happen if the temperature increases, what will happen? The HLB value of your non-ionic surfactant will decrease and it is become more hydrophobic in nature. Okay. At the temperature at which its hydrophobic tendency just exceed its hydrophilic tendency, the phase inversion take place and the emulsion will invert to form a water in oil emulsion. So, at a particular temperature where the hydrophobic tendency or the hydrophobic limit exceed the hydrophilic tendency of an emulsifying agent, what will happen? At that particular temperature, phase inversion will take place and the temperature is called phase inversion temperature, and the emulsion will invert themselves from oil in water to water in oil type of emulsion. Therefore, conditions such or an example conditions or for example, added salt or an increase in temperature which decreases the degree of hydration of the interfacial film also decreases the stability of the emulsion. So, this is a condition that if you are going to increase the temperature, the degree of hydration of your interfacial film decreases, okay, and thereby decreasing the stability of the emulsion. So, as a general rule, the relative stability of oil in water emulsions are obtained when the proposed storage temperature are between 20 to 60 degrees centigrade below the phase inversion temperature, because the interfacial films are then sufficiently hydrated. So, for making a stable oil in water type of emulsion, okay, so the proposed temperature for the storage of such type of emulsions are 20 to 60 degrees centigrade, and that is below the phase inversion temperature, and at this temperature the interfacial film, okay, the surfactant film are sufficiently hydrated. Okay, next is your preparation of emulsion. So, up till now we have discussed about the emulsifying agent, how we discussed about the Bancroft rule, how the temperature will influence the formation of emulsifying emulsion. Okay. So, now we are going to discuss the preparation of emulsion. So, before attempting to prepare an emulsion, it may be necessary to select the important components. So, for preparing the emulsion, we need a following things. For example, a variety of substances have been used for oil phases. For example, we can choose the oil phases such as fixed oil, aliphatic hydrocarbons, beeswax, glycerides, fatty acids and alcohols. Generally, it is advisable to prepare an emulsion containing less than about 25% of the dispersed phase in oil in water emulsion. Conversely, product containing high percentage more than 70% of the dispersed phase are likely to exhibit phase inversion. So, for preparing the emulsion, we generally keep the concentration or the amount of the dispersed phase is less than 25%. If the amount or the percentage of the dispersed phase exceed more than 70%, then there will be the more chances of phase inversion. That is, if I am preparing oil in water, then water in oil type of emulsion will be formed. So, next point is your selection of aqueous phase. So, mostly water is used, optimum volume of aqueous phase should be decided, okay, and appropriate phase volume ratio should be selected. So, most of the time mostly we choose water as an alkyl, and mostly we choose water as an vehicle, and we take the optimum volume of the water to make the desired emulsion. Then selection of emulsifying agent. How we are going to select a particular emulsifying agent for preparing either oil in water or water in oil type of emulsion. An emulsifying agent is selected depending on the type of emulsion required. Bancroft rule suggests the nature of an emulsifying agent for each emulsion. Okay. So, the required HLB value can be determined based on the nature of oil phase and type of emulsion. Okay. So, it is essential to prepare a series of sample to study the stability, then the optimum concentration of an emulsifying agent should be obtained. So, what will happen? What is the concept that what type of emulsion we have to prepare? Accordingly, we choose the type of emulsifying agent. Keeping in mind the Bancroft rule, what the Bancroft rule says, that the nature of emulsifying agent will decide the type of emulsion. Okay. And we also keep in mind the HLB value of the emulsifying agent, because to make a stable emulsion. Okay. So, for this what we do? We prepare a series of emulsion. Okay. Series of emulsion with emulsion. Suppose I will take oil in water type, oil in water type, oil in water type. Okay. So, what we do? Either we take a different emulsifying agent, or we choose take a one emulsifying agent and we vary the concentration of the emulsifying agent. So, the maximum stability obtained at the particular concentration of an emulsifying agent or with the emulsifying agent, that emulsifying agent will be we choose for the preparation of emulsion. Then methods, small scale preparation. First is your trituration method. Trituration method includes your dry gum method and wet gum method. Dry gum method, in this method the oil is first triturated with gum with a little amount of water to form the primary emulsion. The trituration is continued till a characteristic clicking sound is heard and thick white cream is formed. Once the primary emulsion is formed, the remaining quantity of water is slowly added to form the final emulsion. So, what we do in this? In this we first take the oil phase, we add a emulsifying agent, that is a gum, and will triturate it with a little amount of water to form a primary emulsion. When the clicking sound is appeared, at that time we understand that a primary emulsion is formed. Okay. So, once the primary emulsion is formed, we add a remaining quantity of water to make up the volume and or to make up the final emulsion. Then wet gum method, as the name implies, in this method first gum and water are triturated together to form a mucilage. The required quantity of oil is then gradually added in a small portion with the thorough trituration to form primary emulsion. Once the primary emulsion has been formed, remaining quantity of water is added to make the final emulsion. So, in this what we do? We first take the gum and the water, we make a mucilage, then we add a little bit we add a little amount of oil into the mucilage and we triturate. Okay. Once the primary emulsion formed, then we add a remaining quantity of water to make up the final emulsion. Another various equipments are employed in the process of making the emulsion, such as ordinary agitators, mechanical mixtures, propeller type mixtures, turbine mixtures, colloidal mills, ultrasonic devices. In this what we do? The oil and water phase containing hydrophobic and hydrophilic components respectively are often heated separately in large tanks. When waxes are present, both phases must be heated above the highest melting point of any component present. Then one phase is pumped into tanks containing second phase. Constant agitation is provided during preparation. After that, emulsion is homogenized. Thank you.